Harvard MIT Math Tournament 2022 Algebra and Number Theory Round. Problem number 4. Compute the sum of all two-digit prime numbers p such that there exists a prime number q for which 100p plus q is a perfect square. Okay, so one of the most useful things in prime numbers, you want, for example, consider mod 2. Considering mod some numbers 2, 3, 5 are most of the time useful for. So here we have two cases. Case 1. If p is even, then we conclude what? Then p is 2. And it will be 100q plus 2 is a perfect square, but we know it's impossible because it is even number, and when it is perfect square it must be multiple of 4, but 4 doesn't divide that, so that's a contradiction. So we have only case 2, p is odd. Now there is one of the most useful ideas is when you have a perfect square and it is odd, then it is congruent to 1 mod 8 means what? Suppose, for example, so because p is also 100q plus p, x squared. So we conclude x is odd because even plus odd is odd. If x is odd, here we only need mod 4, but I want to show you in general for other problems. I'm sure it's useful. Mod 8. So when you consider x squared, it will be what? It will be 4a squared plus 4a plus 1. And if you factor from 4a, it will be 4a, a plus 1 plus 1. And you can consider it is multiplication of two consecutive numbers. If a is even, it is even. If a is odd, a plus 1 is even. So it is always even. So you consider it 2b, and it will be 8b plus 1. So we know it is congruent to 1 mod 8. So obviously, we can say also it is congruent to 1 mod 4, because here it's 100 multiple of 4. So we conclude x squared is 1 mod 4. X squared is what? Is 100q plus p. If you consider mod 4, it will be p, and because it is x squared is 100q plus p, mod 4 it will be 1. Okay, so here it says what? Sum of all two-digit prime numbers p such that there exists. So p can only be two-digit prime numbers, and it must be one congruent when it is congruent to 1 mod 4. So if I check, let's start from the first prime two-digit numbers. 11 is 4k plus 3, so it is not good. 13 is good, 4k plus 1. 13 plus 4, we add by 4 because it must be 1 mod 4, so 17 is good. 21 is not prime, 25 is not prime, 29, 33, 37 is good, 41, 45, 49 is multiple of 7, 45 multiple of 5, 49, 53, and 57 is multiple of 3, 61, 65 not good, multiple of 5, 69 multiple of 3, 73, 77 multiple of 7, 81 multiple of 9, 85 multiple of 5, 89 the next, and 93 is multiple of 3, 97. So we should check 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, only 10 numbers. Also, if we consider mod 5, I said for prime numbers or number theory problems, it's good to consider some mods. So here you say, okay, x can be what? Mod 5 can be 0 plus minus 1 plus minus 2 mod 5. If we consider perfect square, it can be only 0, 1, or 4. And if we check these numbers, mod 5, why? Because x squared is what? Is 100q plus p. And mod 5, it will be p, because 100 is multiple of 5. So we know that p can only be what? 0, 1, and 4 mod 5. So we cancel 13, this 3, it is 2, it is 4, it is 2, we cancel this 1, 3, we cancel 1, 3, we cancel 9, 4, 97, 2 mod 5. So Now we should only check 1, 2, 3, 4 cases. Okay, so it says what? It says the problem says 100Q plus P, that is perfect square, and we need to check P 29, 41, 61, 89. As I said before, try to memorize 1 squared to 31 squared at least. So here we know 529 is what? Is 23 squared. And it will be 100 times 5 plus 29. So because 5 is prime number, so 29 will be okay. For 41, you know 21 squared will be 441, but here it is 4 times 100. 4 is not prime, so it's not good. But also, if we check another number, 841 is also 8. Okay, here we didn't find example. We should check, we should reject it or try each of them. If you say it is not answer, you should reject it. You should prove that it is impossible. If you say yes, that works, for example 61, you should find an example. For 61, I know 19 squared is 361, which is 100 times 3 plus 61. So Q is 3, and that's okay. For 61, we found an example. And for 89, you say, okay, 17 squared is 289, and it will be what? 2 times 100 plus 89. So 89 is also okay. Okay, now when you see, for example, for some numbers, it is so much important. When you see for some numbers, you can't find examples. So also try to check, maybe it doesn't work. So I want to check if P equals 41. So 100Q plus 41 is a perfect square, x squared. Now we say what here? Q, if Q is even, we know Q is prime. So if Q is even, so Q is 2. And if you replace Q with 2, it will be 241, which is not perfect square. So we conclude Q is odd. Q is odd. And for example, it is 2W plus 1. So if you replace here, it will be 200W plus what? Replace Q with 2W plus 1. Plus 100 plus 41 is x squared. We know what? The left side is odd, so right side is also odd, and we've proved that when we have a perfect square, it is congruent to what? It is 8b plus 1. So it's congruent to 1 mod 8. 1 mod 8. And if we check left side here, 200 is multiple of 8. 100, so 100, if you divide it by 8, it will be what? It will be 4. Plus this 1 is congruent to 1 mod 8. So the left side will be, it's 5, the right side is 1. So 5 is congruent to 1 mod 8, and it is contradiction because you can say 8 divides 5 minus 1, which is 4, but 8 doesn't divide 4. So we proved that 41 doesn't work, and the problem wants what? The problem says prime Q for which this is perfect square. Compute the sum of all 2-digit prime. Okay, prime P. Now we should add all these numbers. What number is this? Let me write the rest with black. 29 plus 61 is what? 80, 90. 90 plus 89 is what? Okay, so the answer is equal, sum of them equals 179. Okay, if you had any question about the solution of this problem or other my solutions, feel free to send message to my WhatsApp number in the description and comments. Also, I will release other problems to improve your problem solving. We try to cover the important ideas in math problems. And so for having next videos, subscribe my YouTube channel now and turn on the notification.